And we're live. Here we are. Startup TNT week 89, broadcasting live from Edmonton, Alberta, all around the world. Welcome, everybody. Really happy. It's the very first pitch night of 2021. It took us a couple weeks to get going, but it's great to be back. And I'm so happy to have our friends from the GreenSTEM program, from the clean tech space. We're all about clean tech for the next few weeks. We're doing a great clean tech summit with Actia and Energy Futures Lab. Applications for that are due January 26th. Really want to see a lot of people participating from across Alberta. We got a great investment group coming together, seasoned investors. We got people from oil and gas companies participating. We've got people that are previous VCs, current VCs, brand new angel investors. It's going to be a really good group. I'm really looking forward to it. And next week, you know who's coming next week? The Screen Industries office. Like, we're going right from deep tech scientists to artists. I love it. But without further ado, what we're going to do is we're going to introduce our co-host, Shoma, from the GreenSTEM program. Shoma, how are you doing tonight?
I'm doing well, and I'm really excited to be here with some of the GreenSTEM fellows. So I just wanted to introduce the program a little bit to you guys. So I'll do that now.
Absolutely. You got a few slides to share.
I do. Pretty quick, though. You guys see that? So the GreenSTEM program is oh, we lost it. Okay, so the GreenSTEM program is a pilot fellowship program run by Alberta Jobs Economy and Innovation in partnership with the University of Alberta, University of Calgary, and University of Lethbridge. And we're really excited to be here with Zach and the Startup TNT group. And essentially, the GreenSTEM program allows for a 2-year commercialization runway for high potential entrepreneurial startups. It provides them with some seed funding as well as salary for the 2 years, and entrepreneurial training, mentorship, and network development, as well as access to the university facilities. But really, this program wouldn't be possible without the support of the community. And it's supporting 19 technology companies throughout the pilot, the 2 cohorts, including 25 fellows. And we've involved everyone in the community, from entrepreneurs as advisors, investors, service providers, universities, and community networks. And so we wanted to use this opportunity to thank you for being involved.
Shoma, that's awesome. You know, I got to say, I actually really believe in this philosophy of treating early stage entrepreneurs sort of like graduate students. You know, I have a PhD, so I kind of use the academic mindset. It's like, you got 2 years, treat them like a fellow, give them a lot of leeway, let them come up with great things to do. And so I was honestly super impressed to hear that this GreenSTEM program was launched. And so do you think there's any possibility that they could expand this beyond just clean tech companies? Sure.
You know, the model is definitely expandable, and the University of Calgary has taken it on with some health STEM and other areas. And so we'd really love to see it grow and expand, provide that entrepreneurial culture in the community.
Yeah. Well, you know, I also want to give a shout out to one of your GreenSTEM participants, Future Fields, who raised money at the very first Startup TNT Investment Summit and then went on to Y Combinator. So I know there's a lot of really, really good companies that a lot of them have participated. Another one, Wyvern participated, Nanode participated, Invitech, at least a handful have participated previously. So great to have you guys here. But you know what, Shoma, I think that's probably enough from me. Who's our first speaker today?
So our first speaker today is Apostle from Solar Steam.
Hello, everyone. Thank you, Shoma, and thank you, Zach. Let me just pull up my slide deck on the screen, set myself up. So just ask for a quick confirmation if you can hear me well and you can see the slide deck on your ends. Perfect. Okay, thank you so much. If heavy industry was a country, it would be the largest producer of greenhouse gases on Earth. My name is Apostle Radev, CEO and co-founder of Solar Steam, and our vision is to change this by developing the lowest cost renewable heat. Solar Steam is a Calgary-based private renewable technology company with own IP control. The problem that we're addressing is the high cost and high emissions associated with process heat. We sell concentrated solar thermal systems, and our customers adopt them to reduce cost as well as lower greenhouse gases. The industry segment that we're in, it's called solar heat for industrial process, or SHIP. The essence of this slide is that industry accounts for about 32% of the world's energy demand, and about 3/4 of that is in the form of heat. Something else that is worth pointing out on this slide is that the compound annual growth rate for the solar heat for industrial process market by 2050 is projected to be around the 19% mark. And Solar Steam is looking at obtainable market in the next 5 years around the $200 million mark. Our technology concept is based off the principles of concentrated solar power, but in our particular case, we're strictly after thermal energy applications. The novelty of our technology is a transformative design for northern climate applications that uses double slope membrane structure to help shelter collectors from the harsh weather conditions that we experience here in Alberta in particular. And our system is able to achieve hot water and steam temperatures up to 400 degrees Celsius. Our system will integrate based off the principles of a hybrid operation. So in essence, when the solar potential is there and when the sun is shining, the adopter will be generating their heat using the solar steam collectors. And at night and during the coldest months of the year, they rely on their conventional fired boilers or a hybrid integration with a geothermal facility, just as an example. I mentioned that we're looking at a serviceable market of about 200 million by 2025, but the total addressable market for the industry as a whole, it's close to the mark of $10 billion. And as a matter of fact, we have already started collaborating with a number of potential beachhead markets, which are represent companies in the petrochemical industry, food and alcohol production, as well as heating and cooling. And we have already engaged some of our secondary markets in the healthcare industry, oil and gas, remote communities that rely on diesel, as well as pulp and paper. Our commercialization plan is we're currently in the R&D phase 1, working on developing a 53 kilowatt proof of concept, which under a modular design will be scaled up to multiple 425 kilowatt thermal facilities. And then we'll be looking at facilities in the megawatts range. We have worked really hard on developing a strong commercialization network, which involves working with some of the top research institutes in Canada. We've been very fortunate to receive private and public funding of the likes of GreenSTEM programs through Alberta government, as well as New Brunswick Innovations Funds. And we have been very fortunate to work with a lot of accelerator programs. And I'll also point out a couple of our beachhead market collaborators, which involve Nova Chemicals, Quasens, which is a renewable technology developer in the Caribbean, and Devil's Keep Distillery in New Brunswick. We're currently raising 150,000 Canadian dollars as part of our $500,000 raise. To date, we have $350,000 committed, and we're also projecting a future ask around the $1 million mark in the 2021. We are looking at a burn rate of about $10,000 per month and runway of 24 months. Thank you so much for this amazing opportunity to present. My name is Apostol Radev, CEO and co-founder of Solar Steam. We develop the lowest cost renewable heat. And I'll be happy to answer any questions you might have. And actually, I'm just going to try to do something for the first time. I'm going to pull up a video that we have been working on that I'd like to play in the background during the Q&A session.
Okay. You know what? Maybe, why don't you walk us through how the technology is working in your Q&A session here? That's my first question.
Of course. So we harness the power of the sun on the collectors that you see in the video, and we concentrate the sunlight onto a focal point that has a solar receiver. So we have boiler feed water coming in from the inlet that is turning into hot water and steam coming out of the outlet. And the structures that you see actually help shelter the system from the harsh weather conditions that we experience in northern climates, such as wind loading, snow, and hail, and really help improve efficiency and lower cost of the system.
Okay, and so I think I missed in the middle, like, what is the current stage? Are you raising money to build like an actual working prototype in the field like this, or are you still in the experimental phase in the laboratory?
So I would say that we are very much past the experimental phase. We're currently, we have secured, I dare say, enough funding to develop the first collector, which would represent a single module of what you're looking at. But we are already raising for our next capacity system, which will represent 4 to 8 of these collectors that you're looking at.
Okay. And so do you have the agreements in place with potential partners, like the end users? I know you listed a couple on your slide there. Like, what's the status on those?
So we've had requests for different capacities by some of the companies that were listed, And we also have companies that are very much looking to play and to help us develop some of the pilot systems so that we can further validate assumptions both on the technology generation side as well as the CapEx and OpEx side of our system.
Okay, I think we're over 5 minutes now. We should probably end it, let the next person go. But Apostle, awesome start. My only last question is, have you applied to the Cleantech Summit? Because you definitely should.
I actually have the application open on my screen, so make sure that I do it. Remind me again the deadline. I thought I have a little more time. Thank you so much, Zach. Appreciate the opportunity.
Okay, awesome. Shoma, who we got next?
Yeah, great job, Apostle. Up next, we have Bing Kao from Nanode. Bing, you're still on mute?
Sorry about that. My name is Bing Cao. I'm the CEO and the co-founder of Nanode Battery Technologies. I'm here today to introduce Nanode and show our technology. We have presented at the Startup TNT event before, but for those friends who have seen our presentation, we will present some progress we have made in the past several months. Yeah, so, sorry. At Nanode, what we do is we develop next generation high performance anode for batteries. The world needs better batteries for different applications. For example, the electric vehicle, the portable electronics, and also the intermittent energy storage for renewable energy. And from the previous presentation, you already see solar energy expanding so dramatically over the years. But the underlying technology that underpinning this shift towards expanding our renewable energy is battery, because we do need intermittent storage media for this kind of not very continuous energy input, and store them and output it during the, for solar during the dark hours. Let me give you a crash course of lithium-ion battery. So a typical battery consists of 3 essential parts: the cathode, the anode, and the separator. The reason it's called lithium-ion battery is because these lithium ions then can move back and forth between the 2 electrodes. In that way, we can charge and discharge the battery. In the past decades, most of the advancement in the battery research have been focused on developing better cathode material. But however, we've seen so much improvement of the cathode material now. Well, phone battery and the car battery are getting better and better. Now it has come to the time that the anode need to be also developed to match the future needs. Believe it or not, graphite is a classic anode material, has been used in the industry for more than 30 years with minimum change. It's the time in the battery world that anode time has come. So what we do at Nanode is we make this thin film metal ribbon to replace graphite. Our product not only offer higher energy density, but we can do it in a much simpler way without an organic solvent. What happens is, in a traditional way, we need to mix graphite with conductive binders, organic solvent, and most of the time additives. Mix it together, then form a slurry, then cast it on copper current collector. However, at Nanode, we only use one step from raw material to the final product. We use a technology called melt spinning. We can make this long and flexible metal ribbons in seconds. Then we can cut it into shape and fit into current battery setting. We see ourselves as cell component manufacturer. And in the past 3 months, we're able to improve our product performance to 50% better than graphite. And we are now applying for provisional patent to protect the knowledge. And thanks to GreenSTEM, we have got great support from the government. And we are also hiring talents for our team. Starting February 1st, there should be a new member join our team. And tonight, our CTO, Dr. Peter Savat will also join us. He will also attend the networking event afterward on Discord. I promise you, no one knows battery better than him in Edmonton. He's a true expert in this area. So if you have a chance to talk to him, be sure to bug him with any questions you want to know about battery. yeah, with that, thank you very much. And I'd love to take any questions.
Thanks, Bing. Great presentation. What are the primary applications in terms of batteries that this would be for? Would this be literally any lithium-ion battery, or are you targeting a specific type of battery?
It can be used in any type of lithium-ion battery, but for us, since we are only right now, all capabilities making 1 centimeter wide metal ribbons, we are focused on the small sized lithium-ion battery.
Okay. And what kind of improvement in my cell phone would I expect from one of your batteries? Like 50% longer battery life?
Yeah, first of all, given a fixed volume, your phone can last 50% longer. The battery time, yeah. And yeah, I mean it because as for the volumetric capacity of power duct is also better than graphite, and also the what's the word? Okay, it's just in my head. I forget it. Energy density of the material by gram is also better than graphite. So in the two ways. So first, with the same volume, we perform better. With the same mass, our volume can be smaller.
I see. Okay. All right. Final quick question. What are like some upcoming challenges or business milestones that you're looking to achieve or could use some support achieving?
Yeah, we just talked to a battery manufacturer company this afternoon. So the challenge for us is it's related to the question you asked. Your first question is for most of the battery settings, they are using the standard 45 millimeter wide copper current collector with graphite. So for that setting, it's the most common thing type of battery production line. We kind of smaller than that size. We are kind of looking for a specific production line that make a small sized lithium-ion batteries.
Okay, Bing, I think we should end it there. And Bing, I noticed that you are also applying to the Actia Clean Tech Summit, right? With us, and Actia and ESL. So Bing will be joining us. I hope more people join us. We'll talk further at the happy hour afterwards. Who's next, Shoma?
Thank you, Bing. Up next, we have Amriaza from Roshan Water Solutions.
I think I'm on mute. And presentation. Okay, can you see everything? Perfect. So my name is Amir, CEO and co-founder of Roshan Water Solutions. And I'm here to talk about all about rapid testing of water samples for bacteria. 745 is the number of active boil water advisories that we have in Canada right now. And 25% of them are directly because bacteria were detected in the water. 48 hours is the minimum time that takes to lift an advisory. And in fact, we already know that many of these advisories stay in place for weeks and even months. So the question is why? The crucial step in making sure that the water is safe to drink is to test the water for bacteria. The problem is right now, decisions on the safety of our drinking water are being made every day based on the data that is few days old, because samples have to be sent to the lab and it takes a few days to get back the results. So that is why we have created bioscience. That is our portable device that tests water samples for bacteria on site and only in 1 hour. Of course, we already know that there are competing products out there serving our market. But the only product that allows for rapid on-site and on-demand testing of water samples for bacteria is our product, bioscience. The global market opportunity for such technologies was estimated at about $2 billion in 2018. And we are focused on the North American market right now in 3 specific segments of municipal drinking water, private drinking water, and wastewater treatment. Right now, we have 10 signed agreements for our paid field tests, which are upcoming in the next few weeks. Our target is to have 516 users by the end of 2024, and we are acquiring these customers and users through introductions from one user to the other end user, conferences and trade shows, as well as digital marketing tools, starting with our new websites. Our revenue model is a razor blade model that starts with a one-time sale of the hardware. with a retail price of $2,500. More importantly, we'll have a recurring revenue from the sale of the test kits with the price of $35 per kit. And we also have future monetization of our data center, which is being planned right now. Based on what I just said, we have a conservative growth projection that has some assumptions in it. First of all, we are only considering organic growth with no significant external cash injection. And we are also assuming that we are not going to obtain any regulatory approvals for our test method in this period. So that regulatory approval can actually increase our revenue, especially recurring revenue, by at least 5 times. And we are also assuming that we are not monetizing on our data center right now in this projection. Our team has combined 50 years of experience in water and wastewater industry, business and corporate development, and backend engineering. And we already recognize that there are gaps in our team, and we are planning to fill those gaps with bringing on about 9 to 10 personnel in the next 3 years. In terms of the milestones, we have some important milestones upcoming. Our customer-related milestones are described on top, starting with our paid field test in a few weeks. On the bottom, we have important tactical milestones, such as implementing our circular and assembly plan, as well as working with US EPA to obtain the regulatory approval for our test method. Right now, we are raising our friends and family round, valued at $250,000 in convertible notes in fall of this year. Together with the non-dilutive funds we already have, they are going to support 3 main activities of marketing and sales, customer success, and operations for us. The other ask that we have is getting your help with introductions to investors, partners, and more customers. Thank you very much for your attention, and I will be more than happy to answer your questions.
Amazing, Amir. I met Amir back when you first launched this company. Remember, we were both hanging out at eHub together.
Yeah.
I was working on a few ideas that went nowhere, and look at you, you're building a real company. Congratulations.
I appreciate that. I really appreciate
that. Anyways, if you want introductions to investor, Amir, I know this great place. It's called the Alberta Clean Tech Investment Summit. You should apply. A lot of great investors are going to be there.
That's your pitch. I love it.
Tell us a little bit the breakdown on a per customer basis. How much are you expecting to make from each one of those customers per year?
So at this stage, let me go back a little bit. It's probably not a good idea to do it this way, but so let me come back here. So I talked about this, that we are not assuming any regulatory approval at this stage. We are working on it, obviously. So this is on-demand use. So let me give you an example. For example, one of our end users is Yellowhead County. So we are expecting for them to buy only one device, so one $2,500, and every quarter an order of 10 test kits. So at this stage, we kind of apply these to all other end users. But as I said, if we have that regulatory approval, which we are expecting with the plan that we have to have it in 2023, that could increase their use, Yellowhead County, to 6 times of that. So 60 tests per quarter.
Yeah. Okay. And those paid field tests that you mentioned, like a dozen or so, those are like signed? Those are signed contracts? Or
yeah, they are. So these are all signed contracts. I didn't have more space to put more logos in it. I didn't want to make like a giant logo soup. But these are basically all they're all local. They're in Alberta right now. But these are all in organizations or municipalities who have signed the agreements right now.
You know what? I want to end it here because we're already like over time, Amir, but I know it's really hard to sell to municipalities. You're doing it, so really impressive, and I look forward to learning more at the happy hour.
Yeah. Thank you very much.
So up next, we have Valen from Transion. And he's actually, out of the folks here today, he's one of our cohort 1 fellows from GreenSTEM.
Thanks, guys. Let me just pull it up. Share the screen. Is that good? All right. Yeah, thanks so much. My name is Valen Rezazadeh. I am the founder and principal of Transion Inc. And today I'm here to give you a bit of an overview of what we do at Transion. So what is Transsion? Well, we're a semiconductor startup. So basically, we build microchips, otherwise known as integrated circuits. These are essentially just chips with little tiny circuits on them, which then find their way into larger hardware modules, which go into various series of electronics and so on and so forth. We're mainly focused on wireless chips. So we're building products mainly for communications and radar hardware. We're based out of the University of Alberta, where we use the NanoFab facility, which is one of the best of its kind in Canada. Features this really big clean room where we can make very small stuff. So wireless electronics are very interesting because they require a series of very special materials and process technology to manufacture them. Gallium nitride is a material system that's used in the manufacturing of various wireless chips. It offers a lot of different advantages over competing materials such as silicon, which you traditionally find in computers, including the ability to handle much higher levels of power as well as faster speeds for transmitting wireless signals. And we've developed a new generation of nanoscale GaN devices and the process technology needed to manufacture this stuff, which has basically beat any other offering on the market to date. As you can see at the bottom of the slide, this is an individual transistor, which is contained within a chip that would then find its way into wireless hardware. Here's a wafer featuring a bunch of different chips. This is what we use to actually manufacture the chips on. And then this gets diced up into little chips that then find their way into a package, which goes into somebody's hardware. So our business model is based around the fabrication and sale of these chip products to large manufacturers of hardware systems that you might find at, for instance, in a cell tower or in various other applications. We've identified to date 5 key market spaces that these chips could be used in and that we can offer a really good value prop for. This includes defense, telecom, space, mobility, and industry 4.0. Right now, we're focusing mainly on defense and space, owing to their nature as high margin, low volume market segments. And our plan is to use this to build up a good base of revenue, especially recurring revenue, to then expand into telecom. Telecom is an interesting thing because, as we all know, 5G is proliferating very quickly. And we've identified over $3 to $4 billion in SAM in this market alone. In all of these markets, we're able to offer a lot of common benefits, including much longer signal range, higher efficiency, hence why we're in GreenSTEM, of course, higher bandwidth, and best of all, lower cost of production. There's a lot of different use cases that these chips can be found in, including, for instance, AESA radars. These are high performance radar systems for fighter jets and naval warships. Small cells, as I mentioned, these are going to be big for 5G and also for 6G down the road. Microwave backbone, which includes point-to-point links, which is a supporting feature for fiber optics and harder to reach areas. V2X is a big trend right now in the mobility space. Basically, vehicles communicating with infrastructure on the road. Satellite communications, we all know about Starlink. SATCOM, high-speed SATCOM in low Earth orbit is going to be the next big thing. And as well, this last one, which is something we haven't really gone into very much thus far, but see as a big growth opportunity, is metrology and non-destructive testing of materials in manufacturing environments. We've raised over 1.22 million. Well, we've raised 1.22 million in R&D grants contracts to date. We have lots of customer interest. We've completed our alpha prototype in summer this past year, and we're now paving the road to recurring revenue. And these are our partners that we've worked with, and thanks for your time. Sorry, I went a little bit over there, but
yeah, you guys are all doing 4-minute pitches, but that's okay.
Yeah.
Okay, here, actually, I just want to ask you to finish up on that last statement. You're paving the road to recurring revenue. Expand on that. How does that work? Tell us how we got the road.
Yeah. So basically, right now, we're, like I said, we're focused on very low volume customers because we just don't have the capacity to support we don't have a big fab like Intel that we can manufacture hundreds of thousands of chips, but we're basically focused right now on prototyping contracts with key customers who we've been speaking with. And we're looking, I guess, if I had to say one takeaway from this, is we're looking to speak with, investors and that sort of thing to start to acquire additional capabilities to expand our capacity. So manufacturing equipment, additional human resources, that sort of thing.
Okay. And are the customers you're talking to, what kind of revenue would they represent? It sounds like you're talking to a few on an annual basis, like in 2021 or 2022, if things are working really well.
Yeah. So, I mean, you know, collectively, I mean, our revenue targets long term, and I mean, this is really far down the line, like maybe like 5 to 7 years, but you know, ideally we'd be $100 million a year revenue company, if not more. I mean, overall, there's like a huge addressable market in all of these areas, and you know, our comparables are all in the, you know, $100 million revenue, $1 to $10 billion market cap kind of area. So
Okay. But are you able to are you able to service like these initial revenue contracts with your existing facilities, or would this require you either contracting out to like a larger facility or
yes,
partnering with someone licensing your stuff?
so we're able to actually do a lot of one-offs in-house. Like we can, you know, do prototyping contracts as well as small volume lots. And then we have identified a clear path to, you know, ideally we're going to be working with partners like NRC Nano, like the NRC facility here in Edmonton, to put additional pieces of equipment to expand our capacity. So right off the bat, we should be able to do small lots to generate, you know, upwards. I think we calculated around 5 million is like the where we'd start to cap out 5 to 10 million, and then build on from that with additional equipment.
Okay, you know what, Valen? I just keep talking to you guys. We're over time, and let's end it there. I think we have one more speaker, right, Shoma? Valen, I definitely want to follow up with you afterwards.
Yeah,
And actually,
sorry.
One quick shout out, guys. A lot of you are a great fit for this new meetup that just started called the Hardware Meetup. So you guys want to follow up with me after? I can put you in touch with Tom from Interface Fluidics, really great guy, CEO of a great company that has raised like $5 million. It's like a 25-person company. They operate right here in Edmonton. And yeah, you guys should connect with that hardware community, a lot of you. It'd be a really, really good experience.
Oh, sure. And it looks like Harlan's all ready to go. So next up is Harlan from Alice Bioscience.
Hello, everyone. Thank you for having me. My name is Harlan Brandon. I'm the CEO and co-founder of Alice Bioscience, and we are a new biotech company that develops custom biosensors from naturally occurring proteins that can provide efficient and specific measurement of analytes in solution. And today I want to tell you a bit about our first two prototypes and how they're kind of proof of concepts for what we're thinking of, and how we think they can fit into the biofuel industry. So biofuels are, and the increased usage of them is a key way to help reduce greenhouse gas emissions. And one of the interesting things about biofuels is their production from organic feedstocks. And then this process is actually a little bit more complicated than it seems. And there's either not a full conversion, or there's sometimes toxic byproducts. And being able to monitor these conversion states or toxic compounds can help us increase the efficiency of biofuel production and make so we can actually have better biofuel in our industry. So our kind of unique solution to this is the custom protein biosensors I mentioned at the start. And this is just kind of a rough schematic of what I'm talking about. So our protein-based biosensors are a protein that have a fluorescent dye attached. And as they bind to that target molecule, you have a resulting change in fluorescence, which we can detect and measure to quantify these different components. And our first two are for these breakdown products of starch and pectin, which are major components of the plant cell wall. So you can see how this fits right into the biofuel industry. And the biofuel is a rapidly growing industry, and it's projected to keep growing about 4% year over year. And we think this is kind of a key spot where we can fit our initial prototypes into as biofuels become more and more important, both for transportation and other uses. So our initial business model, though, is to target researchers that actually study carbohydrates and biofuels, because our initial biosensors are still stuck at that lab-based setting. And if we want to branch out to the biofuel production companies, which is our target market, we want to try and develop a system that can be easily integrated into their established infrastructure, so they can get kind of inline measurements of sample as it passes through to get that on-the-fly measurement, so they can have that fine-tuning of the process. And ultimately, we hope to actually sub-license our biosensors to a larger company to produce and distribute them, because we want to be just like production and design kind of company. But we'll see how that goes. So our initial source is to actually make the kits and sell them to researchers. So that's going to be our initial kind of target market and where we're getting our initial revenue. We already have several researchers lined up that want the initial two and have ideas for other biosensors we could make for them, which is kind of a good segue to our other kind of sales route, which would be the custom biosensor side, where we'd design any biosensor people would want, either just give them a list of biosensors or actually fully design and test them for them as well. And that's through our proprietary patent that we filed. Basically, it takes a quick overview, takes a molecular dynamic simulation, so simulates how a protein moves in real time, and takes that information to actually help us make a smart list of places where we could label the protein to turn it into a biosensor. And I could talk about this for a while, but to spare the time and get through my 3 minutes quickly, I'll quickly jump to who our company is. Me as CEO, and Luke Roberts as our Chief Scientific Officer. We're the 2 founders. We're slowly expanding our team to try and get, as we've started to get into lab and start working on stuff. We have a great team of advisors. And with that, I'd be happy to take any questions. If you have any ideas, comments, feel free to contact me anytime.
Hey, awesome, Harlan. Thanks. Great job. I enjoyed this pitch. It sounds like you're moving in a direction of going to biosensors on demand. Is that what that future state is with your patented technology?
That's definitely where we'd like to be, because we like doing the science side of it, not so much the produce and distribute. So,
but you're still hustling. You've got researchers lined up, fellow researchers lined up to buy the product. So that's a brilliant way to start, man. I love that. Tell us a little bit about the economics of that. How much are you selling those things for?
That's a good question. That is actually probably where we're struggling the most right now, is to kind of build up that area of how much to actually charge. Because we can make them pretty cheap, so we can make a pretty good return, but we don't want to also lock ourselves out of the market because no
Those
one
are
wants to
high-end
spend.
sensors, so it sounds like they should be premium to me. I think this sounds like a good conversation over a beer during a happy hour, Harlan.
Exactly.
All right, why don't we end it there, Harlan? I want to thank all the speakers for coming, and maybe Brandon, our new chief organizer from Edmonton, who's been working behind the scenes making this whole thing happen. Thanks so much to him. Brandon, what's going to happen next?
You caught me just as I was in the middle of copy and pasting the Discord invites. I'll put it in there for all the folks on YouTube who may have joined us and haven't joined us at a happy hour before. But it is a completely open, very casual, fantastic place to drop by, get to chat with some of the amazing speakers that we've had here today, some other folks that are in the community, investors, entrepreneurs, people who are just interested in having a yarn about all of this. So if you haven't used Discord before, work up a bit of courage and give it a go. It's not too hard, I promise. And we'll all be there after this. So.
Yeah, and I want to give one big final thank you to Shoma, who organized this, invited all these guests. I really enjoy these presentations. And I also want to give a special thank you to the anonymous beer donor that provided some free beer to a few of these presenters. They have asked to remain anonymous, but that's awesome. I love anonymous beer donors. Thanks so much. Shoma, any parting words for us?
It's been amazing to work with the GreenSTEM Fellows and to see how fast they progress and the progress that they've made, the Cohort 1 Fellows over 2 years, and we're excited to see where they all go.
Okay. Well, with that, guys, please meet us on the Discord channel. Let's have some